Hello, in this lecture we will find the radius of the small circle. In the drawing we have a quarter circle and we know that chord CD equals to 2 units, OD equals to 3 units, and angle BCD equals to 90 degrees. And inside the quarter circle we have a small circle, this small circle, and we want to find out the radius of this small circle. Okay, so first of all we will define the center of the small circle as point P, and then we will join together points A and P by a straight line. Actually, AP is the radius of the small circle. I will mark it as small r, and we will also join together points P and B by a straight line. And we will define the touching point between CB and the small circle as point X, and we will join together points P and X by a straight line, and PX will be also defined as the radius of the small circle, because this line segment exits from the center of the small circle, that is to say from point A, and ends at point X, that is a point on the small circle itself. So PX is the radius of the small circle, and AP is also the radius of the small circle for the same reason. And the angle ABP, this angle will be defined as angle theta. Actually, tangent theta equals to AP over AB. AP over AB, but we know that AP equals to R is the radius of the small circle, so it is R over AB. So actually the radius of the small circle that we are looking for equals to AB times tangent theta. So actually, in order to find out the radius of the small circle, we have to find out the value of AB and the value of tangent theta, and then we will multiply one by the other. We will multiply AB by tangent theta, and this will be the radius of the small circle. Okay, so in the next step we will focus on two triangles, triangle ABP and triangle BPX. I will draw these two triangles again. So here we will have triangle ABP. This is point B, this is point A, and this will be AP. That is the radius of the small circle, and then this will be PB, and then we will have PX, that is also the radius of the small circle, and then we will join points X and B together. So on these two triangles, again triangle PXB and triangle ABP, this triangle ABP. So on these two triangles we will actually prove that those two triangles are congruent to each other. First of all, we know that AP equals to PX, and those two line segments are both equal to the radius of the small circle. Therefore they are equal to each other. And also PB, this side is a common side. It belongs both to triangle APB, and PB also belongs to triangle PBX. So AP equals to AP. It is a common angle. It is a common side. It belongs to both triangles, to triangle APB, and PB also belongs to triangle PBX. Okay, it is a common side, and also AB equals to BX. AB equals to BX. So those two sides are equal to each other according to A side AB equals to side BX according to two tangents theorem. According to two tangents theorem, those two sides are equal to each other. So actually two tangents theorem states that that the lengths of two tangents from common external point to the circle are equal. Again, the two tangent theorem states that the lengths of two tangents from common external point to the circle are equal. So actually, according to this theorem, if we have common external point, that is to say point B, and from point B we draw two tangents to a circle, we have tangent AB and tangent BX, then the length of those two tangents are equal to each other. So AB equals to BX. Okay, AB equals to BX. AB equals to BX according to two tangents theorem. Okay, so we actually proved that all the sides of triangle ABP are congruent to all the sides of triangle PBX. Therefore, triangle ABP is congruent to triangle PBX according to side rule. Actually, we proved that all the sides of triangle ABP are equal or congruent to all the sides of triangle PBX. Therefore, those two triangles, triangle PBX and triangle ABP, are congruent to each other according to side rule. Okay? Okay? So those two triangles are congruent to each other according to side rule. And from the fact that those two triangles congruent to each other, we can conclude that angle ABP, this angle, is equal to angle PBX. So this angle PBX Actually, both those two angles are equal to theta. Okay, angle ABP is equal to angle PBX, and both those two angles are equal to theta. Okay, actually those two angles are both equal to theta. They are equal to each other, and they are equal to theta. Okay, so angle ABP in triangle ABP equals to angle PBX in triangle PBX. Both those two angles are equal to theta according to the rule that corresponding angles in congruent triangles are equal to each other. Again, according to the rule that corresponding angles in congruent triangles are equal to each other, those two angles are equal to each other, both of them equal to theta. Okay, so in the next step we will extend CB and OD until they intersect with each other at point the intersection point between OD and CB will be defined as point E. The intersection point between CB and OD is defined as E, point E. And actually, by this construction, by extending those two line segments OD and CB, we created two vertex angles. We have vertex angle EBO, and vertex angle ABC. Okay, so actually vertex angle ABC is equal to vertex angle ABO, vertex angle EBO. Those two vertex angles are equal to each other according to the rule that vertex angles are equal to each other. Again, vertex angle ABC that actually equals to theta plus theta equals to vertex angle EBO that equals to also to 2 theta. Okay, so vertex angle ABC equals to vertex angle EBO, and both those two angles are equal to 2 theta because it is actually equals to this angle that is theta plus this angle that is also theta. So angle ABC equals to 2 theta, that equals to angle EBO that also equals to 2 theta. Okay, and actually we have here a quarter circle, therefore angle DOB is a right angle because of the fact that we have here a quarter circle. Therefore angle DOA is a right angle. That is to say, angle DOA equals to 90 degrees. And actually it is given us in the question that angle BCD is a right angle, so it equals to 90 degrees, and actually angle BCD is a peripheral angle, so angle BCD is a peripheral angle, and we have a rule that states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. Okay, so according to, I will read the rule again. The rule states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. So therefore we know that peripheral angle BCD equals to 90 degrees. Therefore, according to this rule, peripheral angle PCD rests on the diameter of the circle. So ED is the diameter of the quarter circle. Okay? So according to this rule, DE is the diameter of the quarter circle. And therefore DO equals to R. So R equals to 3, and because of the fact that DO equals to R, then OE must be also equal to R, because the diameter of any circle equals to 2R. So if DO equals to R, then OE must be also equal to R in order to that OE will be equal to 2R. EO must be also equal to R, because we know that DO equals to R. So EO equals to R, that is actually 3 units. Okay? Again, we know that DE is the diameter of the quarter circle, therefore it equals to 2R, and we know that DO equals to R because DO is the radius of the quarter circle, and DE is the diameter of the quarter circle, therefore DE equals to 2R, and we know that DO equals to R, so OE must be also equal to R. Okay? Because DE is the diameter of the quarter circle, so we will complete the quarter circle. We will create from the quarter circle semicircle by drawing a semicircle. So here we will get semicircle, okay, so we constructed semicircle from the quarter circle, and we know that DE is the diameter of the quarter and the diameter of the semicircle. Therefore, it is a straight line. DE is the diameter of the semicircle and the diameter of the quarter circle is a straight line, and we have a rule that states that the sum of the angles on a straight line is equal to 180 degrees. So I write it down. The rule states that the sum of the angles on a straight line is equal to 90 degrees. So I read again the rule. The rule states that the sum of the angles on a straight line is equal to 180 degrees or 180 degrees, and DE is the diameter of the semicircle, is a straight line. DE is a straight line. So if we focus on the straight line DE at point O, the sum of the angles must be equal to 100 or 180 degrees. So at point O we have right angle. This is a right angle, so it is 90 degrees, plus the size of angle EOB must be equal to 180 degrees according to this rule. So here we will subtract 90 degrees from this equality, and we will get that angle EOB equals to 180 degrees minus 90 degrees equals to 90 degrees. Okay, so we found out that angle EOB is a right angle, it equals to 90 degrees. So if angle EOB is a right angle, then triangle EOB is a right triangle. So triangle EOB is a right triangle. Is a right triangle. So we know that the sum of the angles in any triangle equals to 180 degrees. So in the right triangle EOB, the sum of the angles is 180 degrees. So actually 90 degrees plus this angle that is 2 theta plus angle BEO, this angle, must be equal to 180 degrees. So from this equality we will subtract 90 degrees. We will get that 2 theta plus angle BEO equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that 2 theta plus angle BEO equals to 90 degrees. Here we will subtract 2 theta from this equality, and we will get that angle BEO equals to 90 degrees minus 2 theta. Okay, angle BEO equals to 90 degrees minus 2 theta. Okay, so you can write here that this angle equals to 90 degrees minus 2 theta. Okay, and in the next step we will focus on the right triangle DCE. On the right triangle DCE, we know that the sum of the angles must be equal to 180 degrees, so actually the size of angle EDC plus 90 degrees plus this angle, the size of this angle that is 90 degrees minus 2 theta must be equal to 180 degrees. Again, this statement is actually that the sum of the angles in triangle DCE must be equal to 180 degrees. So angle EDC plus 90 degrees plus 90 degrees, angle EDC plus 90 degrees plus 90 degrees minus 2 theta, the size of this angle, 90 degrees. Okay, angle EDC is this angle plus this angle that is 90 degrees plus angle DEC that equals to 90 degrees minus 2 theta must be equal to 180 degrees. Okay, the sum of the angles in triangle DCE must be equal to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees, and in the other side of the equation we have also 180 degrees, so 180 degrees will be cancelled with 180 degrees. So what is left here, the angle EDC minus 2 theta equals to 0. Angle EDC minus 2 theta equals to 0. So here we will add 2 theta to this equality, and we will get that angle EDC equals to 2 theta. Okay, so angle EDC equals to 2 theta. So actually this is angle EDC, it equals to 2 theta. Okay, and we know that triangle EDC is a right triangle, so we can implement the Pythagoras theorem in the right triangle EDC. So in the right triangle EDC, according to the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, so in the right triangle EDC, CD square plus CE square will be equal to DE square. According to Pythagoras theorem. Again, in the right triangle, triangle EDC, CD square plus CE square equals to DE square. Okay? But what is the value of CD? CD equals to 2 units. It is given us in the question. So CD square is 2 square, and 2 square is 4, plus CE square equals to DE square. What is the size of DE? DE equals to 3 plus 3. It is the diameter of the semicircle. DE equals to 6 units. So DE square is 6 square, and 6 square is 36. So in total we got that 4 plus CE square equals to 36. Here we'll subtract 4 from this equality, and we will get that CE square equals to 36 minus 4, that is 32. So we got that CE square equals to 32. We will take the root out of this equality, and we will get that CE equals to the root of 32, and 32 equals to 16 plus 2, 16 times 2, and the root of 16 is 4, so in total we will get that CE equals to 4 times root 2. Okay, CE equals to 4 times root 2. Okay, CE equals to 4 times root 2, and actually tangents 2 theta in triangle CDE. In triangle CDE, tangents 2 theta equals to CE over CD. Okay, again in triangle, the right triangle, triangle CDE, in the right triangle, triangle CDE, tangents 2 theta equals to CE over CD. Okay, but we have already found out that CE equals to 4 times root 2, and it is given us in the question that CD equals to 2 units. So in total we will get that tangents 2 theta equals to 4 times root 2 over 2. 4 over 2 is 2, so we got that tangents 2 theta equals to 2 times root 2. Again, tangents 2 theta equals to 2 times root 2. Okay, tangents 2 theta equals to 2 times root 2. And we know that we have already found out that the radius of the semicircle is actually equals to AB times tangents theta. So in order to find out the radius of the small circle, we must find out the value of AB and the value of tangents theta, and we actually found out that tangents 2 theta equals to 2 times root 2. but we don't need the value of tangent 2 theta, but we need the value of tangent theta. So in order to find out the value of tangent theta, again, we found out the tangent theta equals tangent 2 theta equals to 2 times root 2, and in order to find out the value of the radius, we must find out the value of tangent theta. So in order to find out the value of tangent theta, I will present to you a new trigonometric identity, and from the following trigonometric identity we will find out the value of tangent theta. Tangent 2 theta, according to this trigonometric identity, equals to 2 tangent theta over 1 minus tangents square theta. Okay, so we will use this trigonometric identity in order to find out the value of tangent theta, because we have already found out that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2, and here we have 2 tangent theta over 1 minus tangents theta square. Okay, so here we will define tangent theta as x, and we will find out the value of x. Okay, again, tangent theta will be defined as x, tangent theta equals to x according to our definition. So we will substitute tangent theta by x in this equality, and we will get that 2 times root 2 equals to 2 tangent theta. Tangent theta is x, so it is 2x over 1 minus tangent theta squared. Tangent theta is x, so tangent theta square is x squared. So we got in total that two times root 2 equals to 2 square over 1 minus x squared. So here we will cross multiply by 1 minus x squared, and we get that 2 times root 2, 1 minus x squared equals to 2x. We cross multiply this expression, and we got the 2 times root 2 times 1 minus x squared equals to 2 squared. Here we will open the brackets. We will get the 2 times root 2 minus 2 times root 2 x squared equals to 2x. Here we will add 2 times root 2 squared to this quantity, and we will get the 2 times root 2 equals to 2 times root 2 x squared plus 2x. Here we will divide this equality by 2 and we will get that root 2 equals to root 2 x squared plus x. Here we will subtract root 2 from this equality and we will get that root 2 x squared plus x minus root 2 equals to 0. So we got a quadratic equation. We have here quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. A, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out, and we will find out the value of x according to a new formula. We know that x equals to plus minus root of b squared minus 4 times ac over 2a. So we have here, we'll use this formula in order to find out the value of x, and here in this formula for x, a, b, and c are the coefficients of the quadratic equation. The x is the variable that we want to find out. So in our specific quadratic equation, we know that a equals to root 2, b equals to 1, and c equals to minus root 2. Okay, so we will use this formula for x in order to find out the values of x in our specific quadratic equation. So x will be equal to minus b. B equals to 1, so minus b is minus 1 plus minus root of b squared. B is 1, so b squared is 1 squared. 1 squared is 1. Minus 4 times a is minus 4 times root 2 times c is minus root 2. Minus root 2. So here over 2a is 2 times root 2. So here we got that x equals to minus 1 plus minus. In the root we have 1 minus 4 times root 2 times minus root 2. Minus and minus is plus, and root 2 times root 2 is 2, and 4 times 2 is 8. So in total we will get that in the root we have 1 plus 8, that is 9, over 2 times root 2. So in total we got that x equals to minus 1 plus minus root 9 over 2 times root 2. So x equals to minus 1 plus minus the root of 9 is 3 over 2 times root 2. Okay, so actually we have here two solutions. The first solution is x equals to minus 1, x equals to minus 1 plus 3 over 2 times root 2. So it equals to minus 1 plus 3 is 2, and 2 over 2 times root 2, 2 times 2 is 1, so it is 1 over root 2. So the first solution is that x equals to 1 over root 2, and we have also the second solution. We have also the second solution that x equals to minus 1 minus 3 over 2 times root 2. So it equals to minus 4 over 2 times root 2. That equals to minus 4 over 2 is minus 2 over root 2. So anyway, minus 2 over root 2 is a negative number, and we know that theta is less than 90 degrees because we have a right triangle. So this angle is 90 degrees, and here we have theta. So in the right triangle, the biggest angle equals to 90 degrees. The biggest angle equals to 90 degrees, therefore theta must be less than 90 degrees. Theta is less than 90 degrees, and if angle theta is less than 90 degrees, when the angle is less than 90 degrees, then tangent theta is a positive. Tangent theta is greater than 0. But here we got that x that equals to tangent theta is negative. So tangent theta, x that equals to tangent theta, must be a positive number, therefore x cannot be negative. So this option is incorrect answer. So because x cannot be negative, because tangent theta must be a positive number, so we left only with the option that x equals to 1 over root 2, x equals to 1 over root 2, x equals to 1 over root 2, and we defined x equals to tangent theta. So x equals to 1 over 2, so x equals to tangent theta, so we found out that tangent theta equals to 1 over root 2. Okay? And we've already found out that tangent 2 theta equals to 2 times root 2. As you remember, the radius of the small circle equals to AB times tangent theta. So we have already found out that tangent theta equals to 1 over root 2, and the only thing that is left to find is the size, the value of AB, and after we will find out the value of AB, we will multiply it by tangent theta, that is 1 over root 2, and we will find out the radius of the small circle, that is small r. So in the next step we will find out the value of AB. Okay, AB, here we'll find out the value of this side AB. So in the next step we will focus on triangle BOE, right triangle BOE. In triangle BOE, we know that tangent 2 theta, this angle is 2 theta, so tangent 2 theta equals to OE over BO. But we know that OE is the radius of the semicircle, and it is given us in the question that the radius of the semicircle or the radius of the quadrant circle is the same, equals to 3 units. So OE equals to 3 over BO. BO is BO. Okay, so we found out that tangent 2 theta equals to 3 over BO. 3 over BO, and we've already found out that tangent theta equals to 2 times root 2. So we get that 2 times root 2 equals to 3 over BO. Here we will multiply this equality by BO, and then we will divide it by 2 times root 2, and we will get that BO equals to 3 over 2 times root 2. Okay, BO equals to 3 over times root 2. Okay, so we found out the value of BO. BO equals to 3 over 2 times root 2. We can even write here that BO equals to 3 over 2 times root 2. And in the next step we will connect together points P and O by a straight line. And we know that OA is tangent to the small circle at point A. Okay, OA is tangent to the small circle at point A, and PA is the radius of the small circle. And we have a rule that states that tangent and radius are perpendicular to each other. That is to say, tangent and radius are perpendicular to each other. So the tangent OA and the radius AP are perpendicular to each other. That is to say, angle PAO equals to 90 degrees according to this rule that tangent and radius are perpendicular to each other. Angle PAO equals to 90 degrees. Okay, therefore triangle APO is a right triangle. Triangle APO is a right triangle. That is to say, we can implement the Pythagorean theorem on the right triangle, triangle APO. That means that the square of the hypotenuse in the right triangle APO must be equal to the sum of the squares of the perpendiculars. Okay, so that means that AP square plus AO square, according to the Pythagoras theorem, must be equal to PO square. The hypotenuse is PO, so it is PO square. Okay, again, according to the Pythagorean theorem, in the right triangle, triangle APO, AP square plus AO square must be equal to PO square. Okay, and in the next step we will extend the hypotenuse PO. We will extend the hypotenuse of triangle APO, so we will extend PO until it touches the small circle and also the circle itself at point M. Actually, point M is the point that point M is the point that the small circle and the semicircle touch each other. Okay, point M is the touching point between the small circle and the semicircle. Okay, So actually, if we look, so what is the size PO? The size PO, that is the hypotenuse of triangle APO, equals to the radius of the big circle, that is capital R, minus the radius of the small circle. MP is the radius of the small circle, that is small r. Okay, so actually PO equals to capital R minus small r. Okay, but we know that capital R equals to 3 units, so PO equals to 3 minus small r. Okay, PO equals to 3 minus small r. Okay, PO equals to 3 minus small r. So actually, and AP is the radius of the small circle, so in total we will get that AP square is r small r square plus AO square equals to PO square, but we have already found out that PO equals to 3 minus r, so it is 3 minus r square. Okay, so in total we got that r square plus AO square equals to 3 minus r square. So here we will open the brackets and we will get that r square plus AO square equals to 3 minus r square is 9 plus r square minus 6r. So here we have r square on both sides of the equation, so we can cancel r square, and what is left after we cancelled r square is AO square equals to 9 minus 6r. So here we will take a root out of this equality and we will get that AO equals to the root of 9 minus 6r. We found out the value of AO, and we have already found out that BO is the size of this line segment, or the size of this side. BO equals to 3 over 2 times root 2. Okay, so we have the value of AO, and we have also the value of BO. But what is the value of AB? AB equals to AO minus BO. Again, AB equals to AO minus BO. Okay, AB equals to AO minus BO. We know that AB equals to AO minus BO. So actually AB equals to AO. AO is the root of 9 minus 6R minus BO. BO is 3 over 2 times root 2. So in total we found out that AB equals to the root of 9 minus 6R minus 3 over 2 times root 2, and so that is the value of AB, and we have already found out that tangent theta equals to 1 over root 2, and we know that the radius of the small circle equals to AB times tangent theta. So we know that tangent theta equals to 1 over root 2 and AB equals to this expression. So the only thing that is left to do is to multiply AB by tangent theta, and this will be the radius of the small circle. So we will get that R equals to AB. AB is root of 9 minus 6R minus 3 over 2 times root 2 times tangent theta, that is 1 over root 2. Okay, again, the radius of the small circle equals to root of 9 minus 6R minus 3 over 2 times 2 times 1 over root 2. Here we'll multiply this equality by root 2, and we will get that root 2 times R equals to the root of 9 minus 6R minus 3 over 2 times root 2. So here we will add to this equality 3 times, we will add to this equality 3 over 2 times root 2, and we will get that root 2R plus 3 over 2 times root 2 equals to the root of 9 minus 6R. Okay, we got that root 2 times R plus 3 over 2 times root 2 equals to root of 9 minus 6R. Here we will multiply this expression by 2 times root 2, and then we will divide it by 2 times root 2 in order to have a common factor with this expression. We have 2 times root 2 times R, 2 times root 2 over 2 times root 2 plus 3 equals to the root of 9 minus 6R. So here we have 2 times root 2 is 2 and 2 times 2 is 4. So in total we will have here 4R plus 3 over 2 times root 2 equals to root of 9 minus 6R. So here we will square this expression. So in both sides of the equation we will square both sides of the equation, and we will get that 4r plus 3 square, and here we have 2 times root 2 square is 8, equals to the root of 9 minus 6r, and square of root of 9 minus 6r will be equal to 9 minus 6r, because the root cancels the square. Okay? The square of root of 9 minus 6r equals to 9 minus 6r, because the root and the square cancels the root. Okay? So here we will multiply this equality by 8, and we will get that 9 times 8 times 9 minus 6r is 72 minus 48r equals to 4r plus 3 square. So we got that it is 4r plus 3 square equals to 72 minus 48r. So we will open the brackets here. 4r plus 3 square is 16r square plus 9 plus 4r times 3 is 12r. 12r times 2 is 24r. Equals to 72 minus 48r. So here we will add 48r to this equality, and we will get that 16r square plus 9 plus 24 plus 48 is 72r. All equals to 72. So here we will subtract 72 from this equality, and we will get that 6r square plus 72r minus 63 equals to 0. Okay, so here we have a quadratic equation, and we know that the coefficients of this quadratic equation is a equals to 16, b equals to 72, equals to 72, and c equals to minus 63, and the variable of this quadratic equation that we want to find out is r. So actually we have the general solution for a quadratic equation is x equals to minus b plus minus root of b square minus 4 times a times c over 2 times a. Okay, so this is solution for x, and in our specific quadratic equation the variable is r, so x equals to r. So we'll substitute x by r, and we will get that R equals to minus B, B equals to 72, so minus B is minus 72, plus minus root of B square is 72 square, minus 4 times A is 4 times 16, so it is minus 64 times minus 63 over 2A. A is 16, so 2A is 32. So in total we got that the radius of the small circle equals to minus 72 plus minus the root of 72 square minus 64 times minus 63. So we get here that the radius of the small circle equals to minus 72 plus minus the root of 72 or 72 square is 5,184 plus 64 times 63 is 4,032 and 4,032 plus 5,184 is 9,216. So we get that R equals to 72 plus minus the root of 9,216 is 96 over 32. Okay. So we have here two solutions for R. The first solution is R equals to minus 72 minus 96 over 32. Minus 72 minus 96 is minus 168 over 32 is minus 5.25. Okay, the first solution is that the radius of the small circle equals to minus 5.25, but because of the fact that the radius must be a positive number, this solution is not correct, and the other solution that we will get is that R equals to minus 72 plus 96 over 32 equals to 24 over 32, that is actually 3 over 4 or 0.75. So we found out that the radius of the small circle equals to 3 over 4 units or 0.75 units. Okay, again the radius of this small circle equals to 3 over 4 units or 0.75 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this small circle. We know that the small circle is inside the quarter circle, and we also know that chord CD equals to 2 units, DO equals to 3 units, and angle BCD equals to 90 units, and we want to find out the radius of this small circle. Okay, so actually we defined the center of the small circle as point P. Then we join together points A and P by a straight line. AP is the radius of the small circle because of the fact that it starts from the center of the semicircle and ends at point 8. It is a point on the small circle itself. So AP is the radius of the small circle, and then we also joined points P and X together by a straight line, and PX is also the radius of the small circle. Then we connected together, we joined together points P and B by a straight line, and in triangle APB, and then we defined angle ABP as theta, and in the right triangle, triangle APB, we know that tangent theta equals to AP over AB. Okay, and AP is the radius of the small circle. So again, tangent theta equals to AP over AB, and AP is the radius of the small circle. So we got the tangent theta equals to R over AB, and if we multiply this equality by AB, we will get that R equals to AB tangent theta. So in order to find out the radius of the small circle, we must find the value of AB and the value of tangent theta, and then we will multiply one by each other, and we will find out the radius of the small circle. Okay, then we proved that triangle PXB is congruent to triangle APB according to side rule. Actually, PX equals to AP. Both those two sides are the radiuses of the small circle. PB equals to PB. It is a common side. It belongs to both triangles. And AB equals to BX according to 2 tangents theorem. The 2 tangents theorem states that the lengths of 2 tangents from a common angle, common external point the lengths of 2 tangents from common external point to the circle are equal. Okay, if from external point of a circle you draw 2 tangents to the circle, then the lengths of those 2 tangents are equal to each other. That is to say, AB equals to BX. Okay, so we actually proved that all the sides of triangle PBX are equal to all the sides of triangle APB. Therefore, we proved that triangle PBX is congruent to triangle ABP according to side rule. Okay, and from that we can derive that we can conclude that angle ABC, we concluded that those two angles, angle ABP is equal to angle PBX, according to the rule that corresponding angles in congruent triangles are equal to each other. So if angle ABP is theta, then angle PB and angle XBP will be also equal to theta. Okay. So those two angles are both equal to theta, and then we proved that angle ABC, angle ABC equals to angle EBO, because those two angles are vertex angles, and vertex angles are equal to each other. So angle ABC equals to theta plus theta, that is to say equals to 2 theta. Therefore angle EBO will be also equals to theta, because those two angles are equal to each other, according to the rule that vertex angles are equal to each other. So angle EBO equals to 2 theta. And okay, so angle BCD is a right angle. It is actually also a peripheral angle. Okay, it is a peripheral angle. We have a rule that states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. So peripheral angle BCD or peripheral angle ECD rests on ED. Therefore ED is the diameter of the semicircle, and the diameter of the semicircle equals to 2 times the radius of the circle. In the first time we have this quarter circle, and we know that in a quarter circle angle OD is the radius of the quarter circle, and we found out that DE is the diameter of the quarter circle. DE equals to 2R, so DE equals to 2R, and if DO equals to R, then OE must be equal to 2R minus R, that is to say OE equals to also to R. OE is the radius of the semicircle, and So OE is the radius of the semicircle, and DO is also the radius of the semicircle. And we know that in a quarter circle, angle DOB equals to 90 degrees. Okay, and we know that ED is a straight line because it is the diameter of the semicircle. So we know that the sum of the angles in a straight line is equals to 90 degrees. So the sum of the angles at point O must be equal to 90 degrees. So actually 90 degrees plus the size of angle EOB must be equal to 180 degrees. And if we subtract 90 degrees from this equality, we will get that angle EOB equals to 90 degrees. So this angle is a right angle. Therefore, triangle EOB is a right triangle. And if in the right triangle EOB is, if this angle is 2 theta, then this angle must be equal to 90 degrees minus 2 theta. Okay? And the sum of the angles in the right triangle, triangle DCE equals to 180 degrees. Therefore, the size of this angle plus 90 degrees plus 90 degrees minus 2 theta must be equal to 180 degrees. Again, the size of angle ECD plus 90 degrees plus 90 degrees minus theta must be equal to 180 degrees because the sum of the angles in triangle EDC must be equal to 180 degrees. And from this equality we got that angle EOC, or this angle, angle EDC equals to 2 theta. Angle EDC equals to 2 theta. And then in triangle EDC is a right triangle, therefore we can implement the Pythagorean theorem that states that the sum of the angle and the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in the right triangle EDC, CD square plus EC square must be equal to ED square. Again, CD square plus CE square must be equal to DE square. Okay? But we know that CD equals to 2 units. It is given us in the question. So this CD square is 2 squared, that is 4, plus CE square equals to DE square. DE equals to 3 plus 3 is 6. 6 square is 36. Okay, DE square is 36. So from this equality we got that CE equals to 4 times root 2. CE equals to 4 times root 2. And then in the right triangle DCE, we know that tangent 2 theta equals to CE over CD. Okay, tangent 2 theta equals to CE over CD. And we know that CE equals to 4 times root 2 and CD equals to 2 units. It is given us in the question. So we found out in total that tangent 2 theta equals to 2 times root 2. And we know that the radius of the small circle equals to AB times tangent theta. So in order to find out the radius of the small circle, we will have to find out the value of AB and the value of tangent theta. Okay, we have the value of tangent 2 theta that equals to 2 times root 2. So in order to find out the value of tangent theta from tangent 2 theta, we will use the trigonometric identity that states that tangent 2 theta equals to 2 tangent theta over 1 minus tangent theta squared. Okay, so we know that tangent 2 theta equals to 2 times root 2. So we will substitute tangent 2 theta by 2 times root 2. And we will get that this equality 2 times root 2 equals to 2 tangent theta over 1 minus tangent theta square. And we defined the tangent theta as x, and we got that we defined tangent theta as x, and we got that 2 times root 2 equals to 2x over 1 minus x squared. So actually we got the quadratic equation that root 2 times x squared plus x minus root 2 equals to 0. We solved this quadratic equation, and we found out that x can be equal either to a negative number, but x equals to tangent theta, and because of the fact that theta itself is less than 90 degrees, tangent theta must be a positive number. And if we got for x that is a negative, it is impossible, because x that equals to tangent theta must be a positive number. So this answer is not correct answer, and we left only with the possibility that x equals to 1 over root 2 and x is tangent theta. So we found out that tangent theta equals to 1 over root 2, and tangent 2 theta equals to 2 times root 2, and we have this equality that r equals to ab tangent theta. So, and we found out the value of tangent theta, that is 1 over root 2, so the only thing that is left to find is AB. Okay? And in triangle EBO is a right triangle. In the right triangle EBO, we know that tangent theta equals to OE over BO. In the right triangle BOE, we know that tangent theta equals to OE over BO. OE equals to 3 units, because it is the radius of the semicircle. It equals to 3 over OB. And we already found out that tangent theta, tangent 2 theta equals to 2 times root 2, so we will substitute tangent theta by 2 times root 2. It equals to 3 over OB. From this equality, we found out that OB equals to 3 over 2 times root 2. And then we have a rule that states that tangents and the radius of the tangents are always perpendicular to each other. So angle PAO is a right angle, it equals to 90 degrees. Therefore, triangle APO is a right triangle. We can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AP square plus AO square equals to PO square. And we extended PO until it touches the two circles at point M. From the drawing, we can see that PO equals to capital R minus small r, because MP equals to R, to small r. So capital, so PO equals to MO, that is capital R, minus MP, that is small r, or capital R minus small r equals to OP, and capital R equals to 3, so OP equals to 3 minus R. Okay, so PO square will be actually 3 minus R square. Okay, so we solve this equality, and we found out that AO equals to root 9 minus 6r, and BO equals to 3 over 2 times root 2, and AB, it is actually AB equals to AO minus BO. AB equals to AO minus BO, and we have the values of AO and the value of BO, so we substitute AO and BO by its values from here, and AB actually equals to the root of 9 minus 6r minus 3 over 2 times root 2, tangent theta equals to 1 over root 2, and we know that the radius of the small circle equals to AB times tangent theta. We found out the value of AB and we found out the value of tangent theta, so the only thing that is left is to substitute AB by this expression and tangent theta by 1 over root 2. So we did it, and we got a quadratic equation. That 16r square plus 70r minus 63 equals to 0. We solved this quadratic equation for the radius of the small circle, and we found two answers. The one answer was a negative, but the radius cannot be a negative number, so the only answer that is left is that the radius of the small circle equals to 3 over 4 units, or 0.75 units. Again, the radius of the small circle equals to 0.75 units, or 3 over 5 or 3 over 4 units. Okay, thank you very much.